Hey guys, today we're going to talk about finding the area of both a parallelogram and a triangle today. And we're going to start off with parallelograms. So you might already know the formulas. Today we're going to kind of go into an explanation, like a little visual of how we can derive them. A visual derivation. So let's say we have a parallelogram. We'll do that first. And some of the things we should know about parallelograms: opposite sides are congruent. That's what we're really going to use. So in this parallelogram, let's say, call the top here the base, call it B for base, and we'll call this, we'll call it A, just because. So we have B, we have A. And to find the area is defined as like the space of all like the non-overlapping parts. So it's going to be like all this area in here, this white in the middle. So we want to find the area of this. What we're going to end up doing is we're going to go right to this vertex of the parallelogram, and we're going to drop a perpendicular down, making two right angles here. Now in doing so, that's going to be, we'll call that H. Refer to that as the height of the parallelogram. But also in doing so, that's going to break this bottom base, which is also B units long, but it's going to break it into, let's say, B sub 1 and B sub 2. And then we should know that B sub 1 plus B sub 2, that's equal to the whole base. This bottom base is the same as the top up here, just as this is A and this is also A. So if we take this triangle that we have now, I'm going to go over it. We take this triangle in green here, and if we take that and we just kind of like detach it and reattach it to the shape over here, something we should notice is this length of A. If we put that right on top of this side, it's going to fit perfectly because they are congruent to each other. And then, so I'm going to draw that part, that's our A, put that in perfect, and the triangle will fall that it goes straight down because that was a perpendicular with a right angle over here. So it's going to be a right angle, and then this part right here, well, that will still be B sub 1, and we took this whole thing over here and we just moved it. So this is gone now. We picked it up and like mathematically glued it back together over here. In doing so, notice that we create a rectangle. And a rectangle, we know the area formula is going to be length times the width, but in this case, your length is your B sub 2 plus B sub 1 is B, which is B up here, times, well, your width is going to be your height. So the area of a parallelogram is going to be the base times the height. And this little visual is why that's true. It's a visual of what's going on there. So whenever you have a parallelogram, I'm going to take this away now, make a random parallelogram. All you need is to get one of the bases, so B, and then you just need to get that height, multiply together, and that's going to be the area of your parallelogram. And just like that, you're all done. Now let's look into how to find the area of a triangle. So let's go ahead and let's say we have a parallelogram. This will help us explain a triangle. Let's say we have a parallelogram. Again, opposite sides are congruent, and we know the area of this is base times height. And let me draw in the height. This will be our height. The height here will also be the same as the height right there. Those are the same height. But let's say in this parallelogram, we were to draw a diagonal from this vertex up here to this vertex down here. Obviously it is congruent to itself. Notice that that diagonal will divide the parallelogram into two triangles, and those triangles are actually going to be congruent to one another by side, side, side. And this is our base up here, this is the base here. So since those two triangles are congruent to each other, they're going to have the same area. And since they have the same area, and together they make the whole parallelogram, that means each one of those triangles is half the area of the parallelogram, which is where our area for a triangle comes in. It's going to be 1/2 base times height. So for either one of those two triangles, this one down here, that looks like this, with the base, and we still have that height, for that triangle, it's going to be 1/2 base times height. And the other one that's like looking like this, it still would be 1/2 the base, base times the height. So for any triangle you're trying to find the area of, you're just going to take 1/2 base times height. Sometimes you might be dealing with triangles look a little different, where the height might be a little harder to find. For any triangle, let's say, we'll just go with a normal triangle here. Let's say we know the base. The height is defined as the altitude that is perpendicular with that base. So if we're looking at this as the base, then the height is going to be the altitude that is perpendicular with that base. If you were to use a different side as the base, which you can call this the base if you want, then the height is going to be the altitude that is perpendicular with that base. So it would be this length here. So it all depends on what you define as the base. The height is the altitude that is perpendicular with that side of the triangle. So you could have a different base for any type of triangle. You could also, let's say, maybe have like an obtuse triangle like this. And if you want to call this the base down here, well, the altitude be over here. So this would be your height. This little part right here. Let's make those dashed. So this would be your height, the altitude that goes down and is perpendicular with the base. So it all depends on what you define as the base. If you have a right triangle, smart thing to do is to use your legs as your height and your base, because they make a right angle between them. It's also like it's half of a rectangle, which is where your 1/2 base times height is going to come in. Alright, that's all we have for today. Tomorrow we'll talk about Hero's formula. That'll be fun. Alright guys, have fun. Enjoy your day.